In this video for section 3.2, we're going to be looking at exercise 71. In this problem, instead of being given an equation and asked to draw a graph of it, now we're going to be given a graph and we're going to have to write an equation for it. So it says the graph to the right is a complete graph. That is, it is continuous and displays the functions and behavior. So we can see here that the graph is rising on both sides. And that's what the end behavior shows. All zeros are integers. Answer the following questions. List the zeros whose multiplicity is even. So we have 3 zeros here, and our x-axis goes from -3 to +3, and each tick mark represents 1. That's what this information is telling us down here. This is the x-axis scaling, and then this is the y-axis, which goes from -5 to 10, and each tick mark also represents 1. So looking at my zeros, where my graph crosses the x-axis or touches and turns around, I have a 0 at -2, I have a 0 at -1, and I have a 0 at +1. Even multiplicity means that the graph touches and turns around there. And the only 0 where the graph does that is the one at -2. The second question is to list the zeros whose multiplicity is odd. So looking at my graph, I have 2 zeros where the graph crosses the x-axis. And those are at -1 and +1. Part B says to write an equation expressed as the product of factors of a polynomial that the graph might represent. Use a leading coefficient of 1 or -1 and make the degree of f as small as possible. So this is where we build the factors based on our zeros and then add in other things that the equation needs. So I'm going to start with my first 0 at -2. -2, if x equals -2, then the equation that originally came from was x plus 2 equals 0. And this has an even multiplicity. So that means it needs to be raised to the second power. Now it could be raised to the 4th power, the 6th power, or something like that, but this information here where we're asked to make the degree of f as small as possible, that tells me that I want to keep the exponents as small as I can. So 2 is the exponent that I'm going to put on that factor. Now I have my -1, so if that's my 0, x equals -1, then the factor that came from would be x plus 1 equals 0. So I can just move this number over, kind of going in the opposite direction that I would be if this was a factor and I was solving for x. So add 1 to both sides. Here I added 2 to both sides. So x plus 1 is going to be my factor. Now that's an odd multiplicity, so that's going to be raised to the 1st power. Now looking at this hint here about these 0 at x equals 1, there's a slight, what the book is going to call a wiggle in the graph. So if you look at these 2 zeros, where the graph crosses, you see that they look a little bit different. The 0 at -1, the graph is going to cross here a little bit more directly, whereas at +1, the graph is going to kind of flatten out at that 0 before continuing. So you can see that this looks different. And what this wiggle does is it means that that 0 has a multiplicity of 3 instead of 1. So for my 0 at x equals 1, I would subtract 1 from both sides to get the factor, so it's x minus 1, and then this one is going to have a power of 3. So those are going to be my factors that come from these zeros that I have. So you should kind of be able to see how I'm working backwards from having the equation to making the graph, how these steps are kind of working backwards here. So to put together my function, The last thing I need to think about is the leading coefficient. Now, this is a graph that has an even degree, and so if I add up all my exponents here, I should get an even number, which I do. That would be 6, which is even. And since the end behavior is rising on both sides, that means I need a positive leading coefficient. So I can use my leading coefficient of 1. Now, if the end behavior were the opposite, if the arrows were pointing downward, then I would need to have a -1 in front of all of my factors, or just a negative sign, because you don't really need the 1. Since it's positive, I'm going to have +1, which I really don't need to write, so I can just leave it off. So my function here is going to be f of x equals x plus 2 squared times x plus 1 times x minus 1 to the third. And then part C says use the equation to find the y-intercept of the graph. And as you remember, we find the y-intercept by plugging 0 in for x. So I'm going to plug that in to my new function that I just found. So it's going to be 0 plus 2 squared times 0 plus 1 times 0 minus 1 to the third. So 2 squared times 1 times -1 to the third. -1 to the third is -1, and 4 times 1 times -1 is -4. So that's my y-intercept. Now if I look at my graph, does that make sense? Well, looking at the graph, it does look like the y-intercept is probably -4 because this is scaling by ones and it looks like it's crossing at -4. So now you can go ahead and do the homework problems for this section.